A recently discovered protein could help in the development of a new, inexpensive, and highly sensitive at-home diagnostic test for a wide range of viruses. To explain that is Dr. David Taylor, lead researcher from the University of Texas. And I have to admit, I had to read through this research a few times to understand this and really grasp this concept, and it's really fascinating. The genetic tool set that we're talking about is CRISPR. So can you explain what that is and how it works?
Yeah, sure. So CRISPR and its associated protein Cas is a little machine that we hijacked from bacteria. And it's most widely known for its gene editing properties. In our lab, but recently it actually has kind of exploded in terms of its ability to do diagnostic applications as well.
Okay.
So that space is very competitive right now. So in my laboratory, what we were able to do, and it was a collaboration with a laboratory in Utah State, is to identify a new type of CRISPR protein that can identify an RNA molecule, which for instance could be an RNA molecule for a virus, for instance COVID. And once it would detect that molecule, it indiscriminately cleaves other substrates that are there in the cell. And so one of the things that we were able to do is to change the enzyme based on the structure so that it would only cleave what we wanted it to. So it could be a self-amplifying loop and sensor for different RNA molecules.
Got it. Okay, so you say that a test based on this technology could really combine the best features of a PCR test. What does that mean for the accuracy and really the ability to detect an active infection?
Yeah, so currently the at-home tests look for protein. And they lack the accuracy and sensitivity that happens with the PCR test, where you can look at actually for the viral material, for the viral nucleic acid itself. So this could be something that's inexpensive, could actually look for the viral nucleic acid itself. And so it'd be much more sensitive than the at-home test now. And we think we could probably get it at the right price too. But like I said, I do the basic research. We'll let other people do the commercialization and product development.
Of all of that, okay. And then lastly, what does this mean for people at home? People are watching saying maybe, you know, when can I get this? What are the steps for that? What does it mean for them, and what's the timeline in that process?
Okay, so it's it's a long way from being mailed to you by President Biden. So there's a lot of steps that need to go into this. So we need to do proof of concept experiments. Then people have to show what the sensitivity range actually is, how low can we go in terms of detection. And after all of that is done, it would obviously have to be approved by the FDA and things like that. We'd have to make sure we could use all of those materials in a way that is suitable for at-home testing.
Okay.
So it's quite a ways away.
Yeah, it could be a few years. Okay, well, thank you so much. We'll be, of course, tracking all of your research. Thank you for joining us, Dr. Taylor. We'll be right back.